Hello friends, good morning to all of you. My name is SUDARSHAN, PGT Physics. Today I am able to here to teach about Physics class 12 Science, and it is chapter 9 in NCERT syllabus. So we are going to teach the chapter 9 and its subtopic is 9.6. Let's start this topic. This is 9.6 through the prism, and it is the phenomenon of refraction. Refraction through a prism. Okay. Refraction through a prism. Here refraction and through means through the denser medium or any kind of medium when we study about it, and a prism. And this topic state that the refraction can take place through a prism. What happened? What kind of equation will come? So first of all, know about prism. What is prism? Prism looks like a transparent medium, and it is not a transparent medium, equilibrium transparent medium, hard equilibrium transparent medium. And what is transparent medium? This is a material. It is a hard material, but we cannot see across the object. So it is a hard material, but it is not a transparent medium. This is also an object, and it is also hard material, but we are not able to see across the toy cars. Hot wheel toy cars across cannot see. So it is a hard material, but it is not transparent medium. Then what kind of transparent medium? Transparent medium like this. Before going, we know about the refraction. It represents the transparent medium. What is transparent medium? So let's study the refraction. Refraction. We talk first this one, and then we go to the transparent medium. Light is the speed of light 3 into 0 into 10 to the power 8 meter per second. Light comes from the suns. And what is the reasons when the light comes from the sun? Sun is a huge hot body, and inside the sun the fusion of hydrogen takes place and form helium. The process of fusion of hydrogens to form helium material. In this case, lots of energy released from the fusion reaction. So many stages to form helium. So during this process, the mega electron energy is released. Every forming of or formation of helium. So there are hot hot object of our galaxy. So the light comes from our Earth. So light, its speed is 3 into 10 to the power 8 meter per second, but it is not actual value. Actual value we say 2.998 into 10 to the power 8 meter per second. This is the actual value of the light. Okay, it comes, the light it is also called electromagnetic wave. Electromagnetic wave, electromagnetic wave, and mostly we know that C, it is the electromagnetic wave, you can say electromagnetic radiation. The radiation, the range, our radiation range in range of wavelength, that is 400 nanometer to 700 nanometer. It is called visual light. Visual light, it is the part of electromagnetic radiation, and its wavelength range is 4 nanometer to 700 nanometer. It is called velocity of light. This is a visual, our human eyes, this is C, and this is 3 into 10 to the power 8 meter per second. Approxi, we consider this one approximate per second. So it is an electromagnetic wave. So the range, wavelength range is this and this. This light, it is come from equation like this: C square 1 by mu 0 and epsilon naught. Permeability of the free space and permittivity of the free space. When we put this one and this one value, its value is like this, and C equal to root under 1 upon mu 0 and epsilon naught. When we put this one, permittivity of free space and permeability of free space, this is area, affected area of electric field, and this is the affected area of magnetic field. So we have the electromagnetic wave, the medium where the electromagnetic travel or propagate. So we put this one is we put this is 4 pi to 10 to the power minus 7 into 8.85 into 10 to the power minus 12. When we calculation this one, after calculation we get this one. We are not going to throw the calculation, just we write 2.998 into 10 to the power 8 meter per second. 2.998 into 10 to the power 8 meter per second. After calculation this one, this is the pi, you're putting the value of pi 3.14, and then calculation this one, this is the under root, sorry, just miss, it is the under root of 1 upon 4 pi into 10 to the power minus 7 into 8.85 into 10 to the power minus 12. In the calculation this one, we get the electromagnetic wave, that is called C, and C is the light. It's travel in medium or without medium. It can vacuum, it can travel vacuum or through a medium. So whenever the light comes and strike in this speed, like this speed. This is the C, this is the C, okay, this is the 3. Kilometer per second. Like this, the light speed is so fast. Light is very fast. Whenever the light strikes on any material, whether it is smooth or rough or any kind of shape, hardly a strike on the object, it's when reflect immediately. So if the light is strike like a transparent medium, here with the transparent medium, we rub this one and started this another things. So here, this is a transparent medium. Suppose that this is the transparent medium. Suppose that this is the glass slab. Okay, we can see across the object. We across the material. So this is the glass slab. This one is incident ray. This is the light ray. Speed 3 lakh kilometer per second. Huge speed. So whenever the light strike on any object or surface of the any object, it reflects. So when we take a transparent medium like a glass slab, and what happened is there is refraction, some part refraction, but huge amount of rays of light, or you can ray means it is a consist of the photons. One thing is photon. Photon is the part of our light. Without photon, we cannot imagine it is a light. Light is the quantum theory. So there will be a photon, huge number of photon, and propagate a particular way. So the number of photon strike here, and some is reflect, and some photon, huge number of photon is travel this direction. But condition is that the deviate from this line. This line is called this is the original path of incident ray. That is ray. Even say ray, incident ray, I ray, incident ray, incident at a point P. This point is called point of incident ray over the transparent medium, glass, and its original path of the incident ray. Original path of the incident ray, but it deviates from the original path toward the normal. Whenever the light enter from one medium to another medium, but another medium is what? This is the one medium, but another medium where we place the medium. This is second medium. It is placed in the like this place, permittivity of free space, or air. This is air. Air and glass, two different things. Its density is quite different. There is two medium. difference each other and light travel one to another, then the refraction takes place. Reflection takes place through a light ray. This is mu here, and its value is 1.000229, and the glass slab's value is 2. Mu c equal to, we rub this one, the confusion to u 1.517 something, or u approximate 1.52. This is the refractive index of the prism, refractive index of the air, and any body have the refractive index. But how can you define it, the refractive index of the material? Suppose that this is a transparent medium and it is refractive index. How can we define it? So you know that transparent medium has a transparent things and equilibrium part. When the light incident on air, then it travel in the denser medium, but it deviate toward the normal. In the case this is I and R is not equal to each other, I is R is not equal to each other, then a scientist, Snell's, gives a law, that is Snell law. Snell law, that is mu when the light travel from one to another medium. In this case, suppose the light is travel to from one, then mu 2 into mu 1 equal to sine I upon sine R. This is Snell law. We know about this, and the refraction takes place through the material or transparent material, but it is deviate toward the normal or away from the normal. When it travel from the denser medium to rarer medium, in this case the original path of the denser medium to rarer medium, and whenever the light travel from the denser medium to rarer medium, in this case the light after refraction here, this is P, this is P dash, and it goes away from the normal. It goes away from the normal, and this ray is parallel to each other. But deviate, it is called the lateral shift. This lateral shift comes in when the light passes through the denser medium. So this phenomena is called the refraction. When the light passes one medium to another medium, we can say the rarer medium to denser medium, but provided that there should be a difference. There should be a difference, little bit difference or huge difference, but here is the huge difference, year and class, huge difference. So there will be a phenomena of refraction. There will be a phenomena of reflection. Hence we say that it is the refraction of a light. Huge speed. This is 3 into 10 to the power 8 meter per second. That is 3 lakh kilometer per second. You imagine that when the light travel 3 lakhs kilometer per second, whenever it strike on the surface, it reflect. But whenever it strikes on the transparent medium, then it's deviate toward the normal, and when it leaves it from the transparent medium, it away from the normal. And this emergent ray and the original path of the incident ray, just like difference, it is parallel to each other, and it is called the lateral shift. This type of lateral shift produced after this phenomena of refraction. This is the refraction. But here we talk about the index, refractive index. What is this? What would we know? What is the refractive index? So we go through about it. It is the refractive index. Refractive index. Refractive index also, in short, it is RI, and it is represent mu. This mu, this is refractive index. Whenever the transparent medium we take, air is transparent medium, there also will be a refractive index. Suppose this is glass, this is also transparent medium, and looking this my spectacle, it is also refractive index, also has a refractive index, and so many things are. So here is prism. Prism is also transparent medium, so there will be a refractive index. So we have to find out the refractive index of the prism. If we are taking the shape of this one, this is a triangular shape. What kind of triangular shape? This is a base. This is the base. This is a shape of a rectangle or a square, maybe a square or rectangular, but here this one and this. So this is the shape of triangular shape. This is the triangular prism. It's the transparent hard equilibrium transparent medium. Equilibrium, this equilibrium means the lattice consists of the material or molecule is uniform. So it is or say that it is a hard transparent equilibrium material that is called rectangular shape, and this is the rectangular shape. This is called triangular shape. Triangular shape. Triangular shape. This is the prism in the transparent medium. It has also mu, and the subtopic is 9.6, refraction through a prism. Refraction through a prism means mu equal to sine delta m plus a by 2 and sine a by 2. We have to find out this equation. But here is refractive index. Alright. What is refractive index? Let's go through. Refractive index, that is mu, it is unitless, and it is defined it. Suppose this one is the transparent medium and it is the very hard, okay, and the light travel through this, it bent toward the normal. So what is the reason behind it? When the light travel through the denser medium, it bent toward the normal. What is the reason? So we know the reason about this phenomena or refraction takes place through the denser medium, like a transparent denser medium. This is nothing but the ratio of velocity of light through a vacuum, velocity of light in vacuum and velocity of light in a medium, in a medium. The ratio of velocity of light in vacuum, the speed of light in vacuum is greatest other than any material. So maximum velocity in vacuum, and it is approximately equal to the air. You can see the air. Here is air. Around this material, it is a transparent material, and around the surrounding object is air. Air is also transparent medium, but not dense. It is a rare medium. Air is so the velocity of the light in vacuum is equal to the velocity of light in medium, like air, equal to. So you can say this is the velocity of light maximum 3 into 10 to the power 8 meter per second. The velocity of light in medium, any medium, that is called Vm, velocity of light in Vm. This is refractive index. But one thing's very important to know that what is the reason behind it? What is the reason behind it when the light bent toward the normal? So, suppose this is the glass slab. Okay, glass slab refractive index is 1.5. Like suppose we are taking the diamond, the greatest refractive index in the world, as well as so many transparent medium are greatest than diamond, like rutile, hematite, and so many things, the greatest refractive index. So they are so glittering due to this reason. So we take the diamond. So suppose the diamond. This is the diamond, and its refractive index of diamond. That is, suppose that we find out the refractive index. This is refractive index for the diamond is 2.42, and the glass, it is also greater than the refraction of the rutile. That is 2.90. These two cases, the light, whenever the light travels through the diamond or the light travels through the rutile, what happens? Light slower or greater? We know about it. Suppose the diamond calculation calculation the speed of the velocity of light through the medium. When the velocity of light through the medium is greater than or lesser than, then we can say the refraction takes place and the main region is here. If less than, in the vacuum, velocity of the light in the vacuum is less than. So we can say that this is the region a refraction takes place and bend toward or normal toward. So right here, this is the refractive index of diamond D. This is 3 into velocity of the medium through the diamond. Yeah. Velocity through the medium. That is diamond. That is diamond velocity. Velocity D. Velocity of the light through the diamond. We know velocity medium. Medium is diamond. So we find out this one into 10 to the power 8, per second. This is velocity medium and 3 into 10 to the power 8 meter per second. This is 2.42 and it divided 242 10 to the power 8 meter per second, and it is 1 point something, 1.129 or 2. This is the calculation. It will be calculation 1.239 actual value. So 239. This is 10 to the power 8 meter per second. Let's check it. This is 300 divided, okay. 300 divided by 242. Okay, this is the right answer. This is 66. This is 66. So how we see here? How would you like to see this? This is the lesser or greater? This is the lesser than the vacuum. So this is the region when the light travels from rarer medium to denser medium, it's bent toward the normal, and it is the slower. The photon, when the strike photon, then it's slow in the photon, because light is consist of the photon. Photon is the energy of the light. So whenever the strike, when the light is denser medium, suppose this denser medium, this is the 3D shape of a slab, when that strike, when the light is strike this one, this is the photon, propagation of photon. Propagation of photon. Propagation of photon. When the strike, the hard body, it is the hard material, like diamond is the hard material. So its boiling temperature is so high, up to lakh. So this is very hard. When it strike, the photon energy travel through the medium. This travel, it cannot travel this one. It cannot travel this one. It's bent. Propagation. This is the normal. This is the normal. Bent toward the normal. Due to these regions, it is slower than the vacuum. Slower. slower than the vacuum or air. This is slower because it's bent toward the normal. When the denser normal, when the travel through the denser medium from the rear medium, it's bent toward the normal, and when the light travel from the denser to rear medium, then it's away from the normal. This is not travel this direction, this is travel here, away from. This is the propagation of light, and light is concept of photon, and photon is strike where, and this is the propagation of light through the medium. This is the region. This is the regions when the light takes place, refraction. So we next topic is next things is prism. We know thoroughly this prism, but it is too much time here, so we stop this teaching. We teach about this prism in next class. So if you like this teaching, like me and subscribe my channel. So thank you for watching this video.